Here's a really common problem shows up on the trig final. It's asked to evaluate a cosine of inverse sine. So let's go do a quick analysis and see how we go about solving this one. The analysis looks something like this. When I have a sine act on an angle, I will have a number. Inversely, inverse sine act on a number that will give you an angle. Okay, so that's why this whole chunk inside is cosine of an angle. We don't know what this angle is, but we can find out what the cosine of this angle is. Now, second thing you need to realize that inverse sine is not a strict function in the normal sense. It's restricted between 90 and minus 90 degrees. The reason is that outside this range, it will not be a one-on-one mapping. Therefore, it's not a function. So for the inverse sine, it's always between 90 and minus 90. That's the angle it will spit out. Okay. And third thing is that sine of inverse minus 2 over 3. Well, since we know this angle is not okay because it's outside the range, the one that we are looking at, minus 2 over 3.6 or so, minus 0.6, it's going to be an angle in the fourth quadrant. So here I drew this angle in the fourth quadrant. Since sine of this angle is equal to minus 2 over 3, well, here's my angle. Sine is opposite over the hypotenuse, and the adjacent side for the side using Pythagorean theorem, that's 5. Since all I have to know is cosine of this angle, that's radical of 5 over 3, adjacent over hypotenuse, I don't really need to or care what the angle is. All I needed to know is what the cosine of this angle is. Alright, now let's write up for the solution. So the solution looks like something like this. Inverse sine of minus 2 over 3 is an angle, and the angle is restricted between minus 90 and 90. That's to say sine of theta equal to minus 2/3. And now reading the sine curve over here, this is how we see theta is going to be in the fourth quadrant, because minus 90 degrees and positive 90 degrees restrict our inverse sine between the first quadrant, that's angles over here, and the fourth quadrant, that's minus 90 degrees. Here what I drew is sine of this theta is equal to minus 2 over 3. Since it's in the fourth quadrant, I can use Pythagorean theorem and figure out what the adjacent side is. I do not need to know what the theta is, because all I'm being asked is to find out what the cosine theta is. Using the Pythagorean theorem and the fact that it's adjacent over hypotenuse is radical 5 over 3. That's the final answer. I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video. Together we can make math easy again. Have a confident day.